Welcome back to day 3 of our program. Today we're going to continue on just like yesterday. And I'm happy to see that everyone is here, I hope. And yes, so today, before I start, I just want to get some few points across. I hope I did check everyone's homework that they uploaded in the homework section, and I really appreciate the fact that you guys are doing that. Uh, and if you guys have any questions about the homework, please leave it in the question and answer channel right now. And we as teachers will try our best to answer you. So if you guys have any questions, please leave it in the question and answer chat about the homework. Okay, it seems like you guys don't really have any questions about the homework. So before I start, I just want to say one thing. For homework, we assigned you guys this thing called Solo Learn, where you guys can learn, what is it called? The You can like get certificates on your own. Please do the Solo Learn and get the certificates. And once you do get the certificates, please upload it onto the show off channel just to show like what you guys did up to. And once again, I can't emphasize this. Please do the Solo Learn on your own, as the name kind of implies, because it will be a great help for you guys as well as us, because it'll help build your guys' experience and it'll help us progress a little bit faster so we can do more exciting things. So, with that out of the way, let's start. So, today we're going to go over 3 topics, which are functions, lambdas, and arrays. Functions and lambdas are very intertwined together, so you guys don't need to worry about that. And today's plan is that I will be teaching the basic how to do functions, lambdas, and such. And then we will have another teacher, Aiden, to go over coding back problems later on. So, without much delay, let's begin. I hope everyone can see this. If it's too small, please let me know. Then I will try my best to do something about it. So, we're going to start with Python functions. So you might be asking, what is a Python function? Well, a Python function is, as it says here, a block of code which only runs when it's called. So it's like, in a sense, it's like an if statement, but it's also not like an if statement. So I'll show you why. So to first create a function, you have to use the keyword def by saying def, and then here it says my function. However, that's just the name of the function, so you can put it as name as anything. So you put the name, you put parentheses. I'll explain what the parentheses are for later on, and then you add the semicolon, just like an if statement. In terms of format, it's very similar to an if statement. However, it's not the if statement. So within the my function, we can put anything along the line of code. In this case, they used print hello from a function. So to use a function, we have to call the function. So what does it mean to call a function? That means we're going to make a function, right? That function only exists and can't do anything unless we call upon its name like this. So imagine this as a person's name. So that person's name is just there. However, we have to call that person's name for them to turn around. And if we don't call that person's name, they'll just stay still. So it works off of that same function. So let's say I change, bye-bye. Let's say I make that function, right? And then I call on it. What will it do? Well, if you run it, I'm using the W3 Schools kind of compiler, so it's a bit slow. So I apologize for that. It's gonna print bye bye, and you can do a multitude of different things, including regular code and such. But I want to emphasize one thing. Let's say I put my function first, and then I put the function. Will it run? Let's see. Let's see what happens to it. If you see here, we get this weird thing. It says name error, which is a error. So why is it getting an error? Because this is like a variable in a sense. And if you can't call on a variable that doesn't exist, if we put the def after my function calling on the name, it means it doesn't exist because it hasn't been made yet. Back to the name example, you're basically calling the name of a person that doesn't exist that's going to be made later on. So, yeah. So that's the basics of a function. So we're going to move on to arguments. So what is an argument? Argument is what goes between the parentheses, like I said before. And the argument that goes in is basically a variable that can be used throughout the function. So in this example, it says the function name takes f name. And f name in this case is a string. So why is that? Because everything is combined as a string. However, let's say I change this to 1. Let's see what happens. Let it load. You see here, we get actually an error, right? It's because you can't change it into an str as this requires. So we're going to go back to, I'm just going to put my name, Sean. And the reason is we're basically initializing this variable that we're going to use later on. It's basically the same, when we make a variable, we name is equal to John. When we do that, we're initializing this variable. We're doing the same thing by putting this in parentheses, and then we're going to specify which variable it's going to specify by putting in the parentheses above, and then we can use it later on. And then just some terminology. Parameter and argument can be used interchangeably when it comes to describing what's between the parentheses. It says here from a functions perspective, but you don't really need to know the definitions of the word per se, because what you really need to know is how to use the code. And the number of arguments is unlimited. Technically, you can have as many arguments as you want, as you see here. To do that, you just need to put two initializing things for this in here. However, if you have two variables that need to be initialized within the function, but you only call for one as such, like here, you will get an error instead. So let's go here and try it. So if you look here, it's Emil is being used for f name, and refsnes is being used for l name, which stands for last name. And basically, this, like I said before, is initializing this, and this is initializing this. So the order does matter. Order is extremely important, as well as the format. So the order of the variables will match the order of this, what is it called? Of variables. However, if I get rid of one, there will be an error. Let it load. There's an error because there's missing one required positional argument. You're required to have one, however, you don't have one. And that way, this function doesn't work because this variable that hasn't been initialized, therefore non-existent, is trying to be used. So there's this thing called arbitrary arguments, or star args. And if you read it's a bit confusing, but if you read the explanation here, I'm just going to read it for you and then explain. If you do not know how many arguments that will be passed in your function, add a star before the parameter name in the function. So what does that mean? That means I don't know how many of the what is it called, variables I need to initialize. So what I'm going to do is I'm going to put a star in front, and once I put a star in front, it kind of turns that variable into an array, or what we like to, or a list, I believe is similar. However, an array is a bit different, so I'll explain that a little bit later. But it changes it into an array or like a list, which uses the same principles, and then you can just get whichever one you want by using the index number. And I just want to emphasize this: index numbers when you can't start from 0. So you know how we take 3 of this, but it prints Linus even though it says kids 2? That's because Emil would have been index 0, Tobias is index 1, and Linus is index 2. So if I were to change this into 0, I should get Emil. Once again, order does matter. for in terms of the index here. So be careful of that. And let's see. I can add as many as I want. Like I won't get an error, even though I add another, because the star just means unknown number. However, let's say I try to go beyond it. 4. We don't have an index 4 because we only have 4 character, 4 values, I guess. And you'll get an error. It says index error. That means I try to go beyond what exists. All right. Okay. Yeah, the parameter and arguments are interchangeable terms that you can use instead of each other. Here it says from a function's perspective, it says here a parameter is the variable listed with inside the parentheses in the function definition, and an argument is the value that is sent to the function when it is called. So what is this saying? An argument. So they're saying this, the ML part is the, what is it called? The argument, and the F name on top is the parameter. Technically, they're interchangeable, like I said, because they're addressing the same variable. However, once again, the parameter refers to the variable that is being initialized, and argument refers to the value that is initializing the variable up above. I hope that was a somewhat satisfying, like, what is it called? Answer? Yeah. And then there's this thing called keyword arguments. Keyword arguments in this case, that means the order does not matter. Why? Is because we're initializing the variables here. We're initializing the variables in here and then sending them up to the variable above. And one thing you have to know is that you have to have the same name. Child 1 has to be child 1. And it has to match to ensure that the order change doesn't really matter. If you look at this example, it's the same thing. Child 3 is Linus, even though it's in front, because child 3 is initialized as Linus. And for the same vein of initializing it within the calling function, calling of the function, you have to add 2 stars in front of the variable name. And once you do that, this if you look here, it's a bit different. The reason why is because when you call it, you have to put quotes within the square brackets. You have to put quotes and the name of the variable you're trying to address, because you have a unknown amount of variables given down here. All right. Yeah. I'm gonna try this. There's this thing called what is it? Default parameter values. Like I said before, parameter is the variable up here. So what does this mean? That means when an argument is not given for country to be initialized as, it will be default to a different the default to the preset initialization. In this case, if we look here, if we put Sweden, it becomes Sweden. If it put India, it becomes India. And if we put Brazil, it becomes Brazil. However, in this one, where in my function, we don't actually add a string, Norway becomes the default, as we see here for country. So yeah. And you can, what is it called? Pass a list as an argument, and it will work in the same way as a regular list. Excuse me. And we can have this thing called a return function. So you might be asking, what's a return function? A return function is basically like a print statement. However, instead of actually printing it onto the console here, the value that this makes will be returned back in place of the my function. So if we look here, print my function 3. So what is my function? My function requires a variable x in this case is 3, and it's going to do 5 times 3, because 5 star x is 3, and that's 15. And we see a return in front. So that means we're not actually printing it out. We're not printing out the return. We're not printing this out. We're taking this and we're returning it back to where it was called. That's why it's called a return. And you can put these return functions function 5. And if you were to do this, let it load, it'll return 25 because my function is simply, in a sense, a variable. It's like a value now because it has to return something. Since it has to return something, this gains a value. Therefore, you can put it into a variable or you can just print it right away. And then there's the pass statement. Pass statement is just a method, as it says here, to avoid getting an error. And it can't be empty. So, yeah, you just got to put a pass. And then there's this thing called recursions, which is basically calling for the, what is it called? The function within the function. It's a bit complicated, so I'm not going to go into depth about it as of now. But just know that when you're doing recursions, you want to make sure you have a return statement somewhere to actually show when the recursion has to stop. And once again, a recursion is basically a function being called into a function over and over again until a certain requirement is met. However, we're not going to use recursions as of right now, just to make sure. A variable, as you can see here. So it says x lambda a plus 10. So when it says lambda a, that means this, when I call for this variable, when I need x, I'm going to have to provide a variable for x to use to determine its value. It's really similar to making a function. It's basically like def x. So return x plus 10. Let's just use the same. Where is it? 10. It's what this is doing is the same as this. However, it's a much shorter way of writing it and a much less complicated way to actually look at the problem. So let's say I change x and then I should get 20 instead because lambda a, the a will take the 10 instead, and 10 plus 10 is 20. So x will be initialized to 20. And like before, like the functions, lambda is technically still a you guys can't hear me. Hello, hello. Uh, hello. Uh, I see. I see. Harriel, can you confirm if you can hear me or not? Hello. Uh, my camera's off too, as well, isn't it? All right. Um. Hello, Harriel. Can you hear me? If you can hear me, please tell me in the chat. If you can't, try leaving and rejoining. Hello, Harriel. Okay. Thank you, Harriet. Yeah. Okay, I'll continue. I'm glad that you can hear me now. So, I'm just gonna explain Lambda really quickly one more time. Lambda is like a mini function, like I said. Uh, is like a mini function. And when I call the name of the variable which lambda is applied to, I have to address a value for that variable the lambda is after to use. And this is the basic format. So remember that. Um, and like a function, because as stated before, a lambda is a function, a very miniature version. It can take any number of arguments technically. And you see it can take 3 as well. And make sure when you put them into the argument that you put the commas in between each number or whatever you're using for the lambda. And yeah, the order does matter, like before, because A will be 5, B will be 6, and C will be 2. C will be 2. So order does matter. So this website does address a very important question, because why would you use a lambda function when we already have functions? So the power of, like it says here, the power of lambda is better shown when you use them as an anonymous function instead of a bigger function. So lambda you can use in regular code instead of functions as a shorthand version, but you can also use it within different functions. There's no limitations. This is the basic format. However, let's do this. So my doubler, it says my function 2. My function 2 has is a, what is it called? My function 2 is a function. Sorry. And it says here it takes an n. However, there's a lambda a, and we require an a, right? So let's try addressing this. So what would be n? N would be my func 2. So n would be 2 in this case. So we know what 2 is. My doubler now becomes a lambda. What is it called? A lambda variable because of the definition of, because of this function up here that requires a lambda. And we say my doubler at 11. To show that better, I'm going to change my doubler's value 10 to 10. No, 2, 5. To show that the n is actually 2, because 2 times 5 should be 10 instead of 2 times 11 being 22. And if you were to run it, yes, you get a 10 because my doubler becomes the lambda variable like I just said, and a will take the value of 5. So let's change what n would be, 3, to prove that actually n is being taken in by the my function part. You get 15 because 5 times 3 is 15. So to use a lambda within a function, you first have to make a variable that takes in the, what is it called? That takes in the functions, addresses the functions, what is it called? Parameters. And then we have to make another variable or just print it out that addresses the lambda within the function. And yeah, there's this example, more examples, and that's lambdas. So before I move on, once again, any questions? Also, please tell me if I'm going too fast. I do have a tendency to talk a bit fast. If you have any questions, please leave it in the question and answer chat. If I don't see it, one of our other Q&A teachers will help you with that if I don't see it. However, I will try my best to see it. So let's move on to another major thing called arrays. It says here, this is important. Python does not have a built-in support for arrays because technically arrays is kind of like a Java thing, but you can use a list instead because they do serve a very similar purpose. And one thing to note, if you do access this page, please note that lists, this page shows you how to use lists as arrays. And if you want to use arrays within what is it called, Python, you do have to import a library known as NumPy library. And so usually you can just use lists instead of arrays because they serve the same purpose. However, I'm just going to show you still. So to create your own array, it's very similar to a list. You write the name of the list you want equals bracket, and then you put quotes. You just, not quotes, you can just put whatever in it and make sure you put the commas. It's very similar to lists. I just want to address that one more time. And it says here, it gives a definition of what an array is. An array is a special variable which can hold more than one value at a time, like a list. And if you see here, it quite literally says, if you have a list of items, and storing the car as single variables would be complicated, so let's just put it in an array that combines all of this. And let's say I have a array made, and I want to get the first one, 0. So it's basically, I don't know how many times I repeat this for some reason. It's basically just a list. If you want to get the first one, 0, second one, 1, for the index numbers, because the index number counting doesn't change. And you can modify the array by using, you just get the index you want and then replace it. If you want the length of an array, we use this function called len. So we're gonna make it first, and then we put len, and in the parentheses after len, we put the name of the array, and then that's gonna return an integer value determining how many not characters, how many indexes are required within the cars. And when we count the length of a list or an array, we start from 1, unlike when we start counting indexes, we start from 0. So please just keep that in mind. That is a common mistake. Yeah, it says here the length of an array is always one more than the highest array index because we start counting at 1 rather than 0. And we can use the looping array elements like the list. So we just do for x being the name of the x is the name of the variable that's going to hold each index that is within cars, or the name of whichever what's it called, whichever array is called. And if you want to add something to arrays, we use this thing called append. So we're just going to put cars being the name of the array, dot append, and then in parentheses we're going to put the new value you want to put in. And if you look here, if we append it, it adds it to the end. It does not add it anywhere weird. It just simply adds it to the end if not specified. And if you want to remove an array, we use this thing called pop. And then so the format is, we're going to put the name of the array. Then we're going to put dot pop. And then in parentheses, we write either here, like it's here, the index number to get rid of Volvo. It'll change the length of the array because it gets rid of it entirely instead of just leaving it as null. Or you can use this thing called dot remove. So what is dot remove? Dot remove is like quite the opposite of pop. Instead of finding the index number to replace it, we're going to find where the specified value is and then pop that version. So it says here, cars that remove Volvo. Cars being, once again, the name of the array, dot remove, and then in the parentheses, write the value you want to get rid of, not the position, which you want to get rid of, the value. And like it says here, it only removes the first occurrence of the value. So what does this mean? Let's say Volvo appears more than once. Dot remove will only remove the first occurrence, the first time it appears. So if I were to print it out. Oops. Let it run. It doesn't get rid of the second Volvo because it only gets rid of the first occurrence, like I said. And there's different methods for arrays, which you guys can probably access through W3 schools, but I'll just quickly do a rundown. Append will add an element at the end of the list. Oh, for the basic format, it's the name of the array dot whichever method, parentheses, and whichever thing is needed for the certain method. Append will add something from the end of the list. Clear will remove everything from the list, basically empty it. Let me just open this to show you. So if I do dot clear doesn't require anything because it's going to empty the entire thing. If I were to do clear, it's going to return to me an empty array because like the word clear means it gets rid of everything. And if I do top dot copy, it's just going to make an exact copy of this. Uh, Another one, and it returns a copy. And then count returns the number of elements within the specified value. Let's see. Yeah, if you click on it, you'll get like examples. If I do count whichever value I want, it'll return how many times it appears. I can just, yeah. And then there's extend, add the elements of a list to the end of the current list. Let's see it in action. So basically, we're just combining two different, what is it called? Arrays together. We're just combining it as one. And then we have dot index. Basically, we're going to look for, like the remove, it goes for the first time it occurs. So it just gives you the index of the first time it appears. Insert puts an element in a specified position. So you have to put the, what is it called? The index you want it as. One thing to note about the insert function. Once you add orange into position 1, banana was the original position 1. However, it is no longer position 1 and is technically position 2 because orange 1 took position 1 and shoved banana to the position 2. There's pop, which I explained. Remove, I explained as well. Reverse basically just flips the order of the entire thing. Original, if I were to do apple, banana, cherry, if I reverse it, it becomes cherry, banana, apple, as you can see. And then lastly, we have sort, which sorts the list based on order. In alphabetical, it goes alphabetically or numerically. We see here BMW, Ford, Volvo. However, I'm going to show you something. Let's say I lowercase it. What do you think will happen? Nothing, because it doesn't really matter in this case. It only really matters within Java, I believe. And once again, Python does not have any built-in support for arrays, but you can just use lists instead. But if you lose list, I don't know if you can use these methods per se. And if you want to use arrays, you have to import it from the library. However, usually you can just use lists. Yeah. So today we just, in terms of the lesson, we went over functions, arrays, and lambdas. Now we're going to move on to some coding back problems, which Aiden is going to go over instead of me. So before I move on, I just want to mention one thing. Please do your solo learn and try to get the certificates. And once you do, please put it in the show off channel. We would really appreciate that if you do that. And it'll be good for you too, as well as we appreciate it. So, yeah, please do your solo learn. Thank you for doing your homework, guys. Today we went over functions, lambdas, and arrays. If you have any questions, please put it in the question and answer chat, and then we will try our best to address it. And yeah, if you guys want to go over our lessons afterwards, there's usually a recording of it that we will upload, or there's the live lecture notes you guys can address. And yeah, so I'm gonna hand it off to Aiden, who's actually gonna do some coding back problems. So that'll probably be it from me today. Thank you, and I hope to see you guys again. I'll probably see you guys again. Yeah, take it away.
Hello, I'm Aiden, and I guess we'll just go over some coding back problems. So we'll go over the sections labeled string 2, list 2, and logic 2. If you go to the Python section, you'll see. Oh, by the way, do you guys have coding bat accounts? Because I don't know if we've done that yet. Well, if you haven't, it should be in the top right. Just press create account and then follow the directions. Hold on, let me share my screen. Sorry. So first we'll go over string two. And there's six in here. So we'll start with the first one, I guess. Um, given a string, return a string where every char in the original there are what? Given a string, return a string for every character in the original there are two characters. So basically, you have to create a function that just repeats every letter twice. So I'll give you like let's give like 3 minutes for you guys to do that, and then I'll give you guys the answer. Okay, it's been about 3 minutes. I'll show you guys the answer. Also, if you guys have any questions, so make sure to post your questions in the questions chat so that people can answer those questions for you if you have any. Um, but yeah, here's one example answer because of course in coding there's a lot of different ways to solve many different problems. This is just one way to solve this specific problem. So first, what we're going to do is we're going to call a variable that is going to be our result. So we'll just have nothing in the string for now. We'll just call it, and we'll since we want to make sure we double every single character, we can try start with a loop. And for every time that we repeat our loop, we want to have um, our resultant string add basically the character that we have. So our resultant string and every time we just add the character twice. And since we're doing that for every single character in our input string, all we have to do, all we have left is just to return the resultant string. Did anybody have any questions about that? Oh yeah, sorry. So yeah, we'll move on to the next exercise. Return the number of times that the string hi appears in any given in the given string. So for this one, yeah, I'll give another 3 minutes for you guys to try and solve this one. And yeah, if you have any questions, just post them in the questions chat. Okay, so I'll give the answer for this one. Um, so here, what we're gonna do, we're gonna start by calling a variable that is going to keep track of how many times that we've encountered the number hi in the string. Afterwards, we want to check for basically every single um, we want to check for every single character whether that part of the string has the word hi or not in it. So what we're going to do is we're going to um, repeat for every single for however long the string is. So in order to do that, we can do for I in range, so every single character in the range of the length of the string. But then and then -1 because we don't want to go too far forward. Because if we were to check for the last one, obviously it's not going to be high because high is a it's two character string and it can't be at the last position. As for what's inside the for loop, every iteration that of the for loop, we want to check if there is the string hi. So we can use the if statement and check if a certain portion of the string, in this case, the character that we're on, all the way to the character +2, because as you know, when we're doing this, the first one's inclusive, while the part to the right of the colon is exclusive, and we want to check if that has high in it. So if it does, we can increase our count by 1. So every time that we encounter the number high, or so every time we encounter the string high, we'll increase the count by 1. And all we have to do left is just return our count. And there you go. I'll leave this up for a little bit longer just to make sure everyone gets it. Okay. We'll go to the next one. Next one, cat dog. Return true if the string cat and dog appear the same number of times in the given string. So this one might take a little longer, but yeah. I'll give you guys 3 minutes to do this one. Okay. I think I've given enough time for that. So we'll start, and I'll give you the answer for this one. So first, we're going to set up 2 variables, one for the amount of times that we encounter cat, and one for the amount of times that we encounter the string dog. And just like we did for the previous problem, we're going to have to check for each string, or each part of the string, whether that part is a cat or dog or neither. So again, we're going to do for I in range of the length of the string, and then -2, because you can't have cat or dog be at the last 2 last 2 characters of a string. So first, we're going to check if a portion of the string is it says the word cat. So, like we did last time, we're going to. Oh, sorry. We're gonna check if that portion starting on character on the character I is equal to or has the string cat. And if it does, we're going to increase the count for cat by 1. And then you could basically just do the exact same thing, but with dog instead of cat. So if we encounter the string dog, then we increase the count of dog by 1. And then all we have to do left is just return count of cat is equal to count of dog. And yeah, it's also been brought to my attention that that you're allowed to do a dog count function, which counts the amount of times that a certain string appears. But I feel like this way would probably be better practice for you to practice your for loops, your if statements, all that, your variables. But you're free to use either way. I don't really mind. Okay, we'll continue on to the next one. Um, so next one, count code. Return the number of times that the string code appears anywhere in the given string, except we'll accept any letter for the D, so cope and coup count. So yeah, I'll give a few minutes for you guys to finish this or try out this problem. And yeah. Okay. I'll go over the solution now. Or if you guys need more time, then by the way, if I'm going too fast or if I'm going too slow, please make sure to let me know because I'm not exactly sure like how fast you guys are able to do these. So yeah, just make sure to let me know if I'm going too fast or too slow. But here we want to count number of times that CO something E appears in the string. So once again, we'll initialize a variable of that tracks how many times it appears. And like the last few, we're going to do the exact same thing in order to figure out how many times it appears. So for I in range of the length of the string, and then minus 3, because like I said, code is a 4-letter word, can't appear in the last 3 characters. And we're going to check if the part of the string starting with the character I going all the way to I plus 2 is equal to co, and the last part of the string is equal to E. And notice that we don't worry about what happens in the between the CO and E, because like we said, the D doesn't count. It doesn't really matter what goes in there as long as these two conditions are met. We'll be able to count it. So if this condition is met, we increase our count by 1. And then we just return the number of times that we counted. So this should work. Yeah. I'll leave it here for a little bit. Okay. So here's the next one. And other. Given 2 strings, return true if either of the strings appears at the very end of the other string, ignoring upper and lower case differences. And so in other words, the computation should not be case sensitive. And yeah, the little hint there, s.lower returns the lowercase version of a string. So yeah. I'll give you a few minutes to do this one. This one isn't super hard, in my opinion, but yeah. Okay. I'll go over the answer now. So first, since we need to make sure that it ignores upper and lowercase differences, we can create new strings by assigning our strings to their lowercase versions of themselves. Because if we assign both of these to the lowercase version of themselves, then it doesn't matter whether it's uppercase or lowercase at any point. So from here, yeah, okay. From here, we can just, this might be a little complicated but you can just return here for the first string from negative length b to the end, where basically here we're just making sure that the like we're making sure that b is at the back end of a, because if you remember, if you start at a negative position, it goes backwards from the end, instead of starting from the front and then going forward. So this basically just gets it from however long the string b is, backwards from the original, because we're trying to make sure that it's at the very end of the string, not at the very start. And then we can also do this. Oh yeah, sorry. We have to make sure that's equal to b, because this is just getting the string from the length of b to the end. So it can either be that or the other way around, where we have a at the end of b. So here we do essentially the same thing, but the other way around. So that to the end is equal to a. And then this should just work. Yeah. This one was a bit confusing, so if you have any questions, that's understandable. I'll wait a bit to see if anyone does have any. Doesn't seem like anyone has any questions, so we'll move on. This is the last one in string 2. So XYZ there. Return true if the given string contains an appearance of XYZ where the XYZ is not directly preceded by a period. So XXYZ counts, but X dot XYZ does not. This one's a little complicated, but it should be well within your skill levels. Yeah, I'll give a few minutes for you guys to try this one. Okay. I'll go over the answer for this one. So for this one, it's really similar to the ones that we had previously, where we had to count the number of times that a certain string appears in a bigger string, except with two key differences. One being that um, there is it's a true or false, so whether it is there or whether it isn't, and the other one being that there is um, it's not allowed to be preceded by a period. So we'll start off really similarly. So we'll do the for I in range of the length of the string. And we're going to check if we're checking whether XYZ has a period in front of it and whether it's there in the first place are all going to be done in this one if statement. So if the string at the position of I is not equal to period, and the string or the string between I plus 1 all the way to I plus 4 is equal to XYZ. So if both of these statements are met, we want to return true. However, this actually doesn't account for the first string, because if we start at 0, it's always going to check for period at 0. So if it starts off with XYZ, it's never going to check if XYZ is at the start. So we'll just do that one separately since it's just a special case. So if the string from 1 to 3, or 0 to 3, sorry, is equal to XYZ, we'll also return true. And of course, I mean, if there's anything else, if we just return false. Yep. So I'll leave this here for a little bit in case anyone has any questions. Okay. That is it for the string twos, I believe. Yeah, there's nothing else here. So we'll move on to logic 2. Logic 2 is the one over here. So we'll start with make bricks. Logic 2, make bricks. We want to make a row of bricks that is goal inches long. We have a number of small bricks, 1 inch each, and big bricks, 5 inches each. Return true if it's possible to make the goal by choosing from the given bricks. This is a little harder, and it looks and can be done without any loops. So yeah. Sorry. Yeah. I'll give like 4 minutes to do this one. Yeah, and I'll give you guys the answer then. Okay. I'll go over this one now. This one is I think we should do on one whole line because it's really just one simple thing. Um, so we're gonna start with the return, and I'll write out the whole thing, and I'll explain to you guys what I've done in each portion after I've finished writing it out. And this should work. Okay. So I'll explain what's going on here. So first we want to make sure that so as you know, this is a modular symbol. So we're making sure that um, the if we divide goal by 5, we wanted to have like more 0 or more. Otherwise, it just won't work. Um, and we also want to make sure that um, however many is remaining, minus small is less than 0, because we want to make sure that because if we go up by 5 and there's a remainder of 3 and we only have 2 small bricks, of course we can't make it no matter how many 5-inch blocks we have. So like if we had like a million 5-inch blocks and then three 1-inch blocks, and then we wanted 4, that would just be impossible because we can't use any 5s, but we don't have enough 1s. So we want to make sure that we can cover that whatever's left via 5s with the amount of 1s. So that's what this part of the code is doing. And this part of the code is making sure that if we were to add up all of them, we want to make sure that they would actually reach our goal. Because if we have like a million as our goal and we only have one big, one small, of course we wouldn't be able to make that much because the maximum we would be able to get is 6. So that's what this part is doing. And we're making sure that all 3 of these are happening at the same time. So we need to make sure this one's good, and then this one's good. Because if any one of these aren't satisfied, then we're not going to be able to make the amount that we need. So yeah, this one's a bit confusing. So if you have any questions, you can say them. Okay, we'll move on to the next one. Lone sum. Given 3 integer values, a, b, c, return their sum. However, if one of the values is the same as another of those values, it does not count towards the sum. So, yeah. Um, by the way, just making sure that you guys know, both of them don't count. So over here we have a 3, 2, 3. Both threes don't count. Only the 2 counts. So yeah, I'll give you guys a few minutes to try this one out, and I'll come back in a bit. Okay, we'll go over the problem now. So for this one, we can use the fact that um, if two of them were to be equal, then whatever's left is the only thing that could possibly count towards the sum, unless that one's also equal to whatever the other two are. So one thing we can do is just if one of them is equal to the other, then we can just return whatever's left because that's the only thing that's going to count towards the sum. Um, I don't know if there's any better way to do this, but you can just do this and just do that for every single thing or like every single relation. And once we do this, um, there's also one more case that we have to account for, which is what if all three of them are the same, like this one. So what we can do there is just make sure that if they're all equal to each other, so like this, we can just return 0 because if none of them count, then the sum is just 0. And if none of these conditions are met, we can just return the sum of each of these. So A plus B plus C. So basically what's happening here is if any two are equal, we just return the last one. And if they're all equal, we just return 0. And otherwise, if none of those work, we just return the sum. Well, what? Something wrong here. Oh, okay. Make sure that you have this at the start because we need to make sure that it checks for this first. Because if we check for this first, let's say we're putting this one through this, and if it sees that, oh, the first two are both equal to 3, it's always going to return um, whatever the last one is, which is 3. But since 3 is also the same as these, we want to return 0. So make sure you guys pay attention to like the order that you put your code, especially if you're doing it this way where you have a bunch of returns after each other. So yeah, just be wary of that whenever you're writing code in general. Yeah, I'll leave this up here so you guys can look at it for a little bit. Oopsie. Sorry. Okay. I'll write it. Like, hold on. Yeah. It's if you missed it, it's in live lecture notes, so you guys can look at that. Sorry. That was my bad. But we'll just go on to the next one. Lucky sum. Given 3 integer values a, b, c, return their sum. However, if one of the values is 13, then it does not count towards the sum, and values to its right do not count. For example, if b is 13, then both b and c do not count. Um, I'll give you guys a few minutes to try out this one, and I'll give you guys the answer later. Okay, we'll go over this one now. So first thing you do here is we want to check if any of these three are 13. So well, okay, let's look at what happens if any of these are 13. So if the first one is 13, then we know that none of them count towards none of the numbers count towards a sum. So we can just return 0 because we know that's just going to end up as 0. If b, if the second number is equal to 13, then everything that counts is just a. So we can just return a. And lastly, if c is equal to 0, or sorry, 13, then all we need to do is just return a and a plus b, because the a and b are counting towards the sum while while c is not. And lastly, if none of them are 13, then we just return a plus b plus c. Yeah. Okay. We'll move on to the next one. Oh. Um. Sorry, I think my computer's. Oh, sorry. Okay, we're back. Sorry, I think I cut out for a bit there, but I didn't say anything important. Okay, no teen sum. Given three integer values, a, b, and c, return their sum. However, if any of the values is a teen in the range 13 to 19 inclusive, so basically just anything that has the word teen in it, then that value counts as 0, except 15 and 16 do not count as teens. Write a separate helper, write a separate function, a helper def fixed teen, which takes in an int value and returns that value fixed for a teen rule, so that you can just avoid writing 15 and 16 don't count like a million times. Define the helper below at the same indent level as the main no teen sum. So I think this is the first thing that requires you to write another function. I mean, technically you don't have to write another function, but it's a lot easier to write that way. So yeah, I'll give you guys a few minutes to try this problem. And yeah. Okay, we will go over this one now. So what we'll do first is we'll create a new function, fix teen and a number. So oops, if if n is in, and we'll just well, we're here, we're just checking if n is in just any of these. Oh, whoops, not 15, 16, 17, 18, 19. And here we're just checking if it's in this area. So a teen that's not 15 or 16. Because if it is, then we can just return 0. Because that's what we do if we get a teen. Otherwise, we just return the number. So for example, if it's 15, then we return the n. We return 15 because it's not within this. But if it is a number within this, then we just return 0 because the value counts as 0 if it's a teen, not 15 or 16. So if we go back to our actual function, all you really need to do is just return. We just need to do fix teen on every single one and just do the sum of that, because the only parameter is whether it's a teen that's not 15 or 16. So that's all we need to really check for here. And we can check for it by using this function. So yeah, that works. I'll leave it up here for a little bit. Okay, and we'll move on. Next one, round sum. For this problem, we'll round an integer value up to the next multiple of 10 if its rightmost digit is 5 or more, so 15 rounds up to 20. Alternately, round down to the previous multiple of 10 if its rightmost digit is less than 5, so 12 rounds down to 10. Given three integers, a, b, c, return the sum of their rounded values. To avoid code repetition, write a separate helper, def round 10 num, and call it 3 times. Write the helper entirely below at the same indent level as round sum. So basically, what we're doing here is just rounding each value and then just getting the sum of their rounded values. So I'll give you a few minutes to try that one out. Oh, sorry, am I going too fast? Yeah, sorry about that. If you guys want, I'll give you guys a little more time to try out this problem. I'll give you to like, I guess, like 40, 45. Yeah. Okay, we'll go over this one. Now. Um, Sorry if you guys weren't able to do this one. Sorry if I'm going a bit too fast, but we're running out of time a little bit. So, um, first thing we'll do is define another function. So round 10, and there's our variable. So so here in this function, we just want to round like normal. We just round to 10. So we can just return, or sorry, not return. If and mod 10 is greater than or equal to 5, we want to return n plus 10 minus n mod 10. Because what that will do will, whatever the remainder is, we just add 10 and then minus that. Or sorry, we're essentially taking away all the remainder and then adding 10 to round up. Otherwise, we just return um, our number minus the remainder. Because if you look at it, for example, 16 here, a remainder, if we divide by 10, is just going to be whatever is in this area. So by taking away what's in that area, we can either round down or round up. And well, but to round up, we can just take away that and then add 10, because what we're essentially doing there is just adding whatever's left to get up to the next 10. And to round down, we just take away the remainder. So now we can get to our actual function, where we do essentially the same thing, where we just do the function to each of our numbers, because that's the only parameter that they're looking for, where we just round to 10 for each of them and then add the sum of our rounded numbers. So basically, we're rounding A, we're rounding B, and we're rounding C. and we're just adding them up over here. Where do I have something wrong? Oh, forgot a plus. Oh, that's why. Hmm. Okay. Do you guys have any questions about this? Okay. So here's the next one. Close far. Given three integers a, b, c, return true if one of b or c is close, differing from a by at most one, while the other is far, differing from both other values by two or more. Also note abs of num computes the absolute value of a number. So here what we want to do is just make sure that we want to make sure that either B or C is either the same or differs by one from A, and we want the other one to differ by two or more for both values. So, for example, one thing that wouldn't work is, well, I mean, there's some examples here, but something that wouldn't work would be like one, like 0, 1, 1, 2, 0 wouldn't work because 0 doesn't differ from 1 by a value of 2 or more, but 1, 2, 4 should work because 4 differs from 1 and 2 by at least 2 or more. Also 1, 4, 2 would work because the first number and the last number are 1 away from each other, while the middle number is differs by a value of 2 or more from the other two. So basically, it doesn't matter which way around the last two numbers are, as long as it fits the descriptions for close and far. So I'll give you guys a few minutes to try out this one. Okay. I'll go over this one now. Um, so what we want to do here, right? We want to check if B or C is close and the other one is far. So we're going to make two conditions. One where B is the one that's close and C is the one that's far, and the second condition being vice versa, where C is the one that's close and B is the one that's far. So first we want to make sure that whether B is close. So we want the absolute value of the difference between A and B to be less than 1. Because if A is like 3 and B is 2, 3 minus 2 is 1, and the absolute value of 1 is just 1. But if we have B bigger than A, say 3 and 4, it still differs by 1, but 3 minus 4 would be negative 1. So we have the absolute value there to make sure that it returns 1 instead of negative 1. We also need to make sure that C is far. So we apply the same concept and we make sure that that C. Also note that we have to make the one that's far differing from values by 2 or more from both of them. So that means we have to do it we have to make C differ by 2 for both A and B. So what we're going to do is just essentially the same code where we have the absolute value of the difference between B and C be greater or equal to 2. And we do the exact same thing for A and C. Our second condition is where B is the one that's far and C is the one that's close. So we'll do the same thing, except all of the values for B and C will be switched because we're switching the values of B and C. Something interesting is that it doesn't matter whether you do B minus A or A minus B, because either way, the absolute value of their difference is just going to be equal to is always going to be the same whichever way you do it, whichever way around you do it. So after we've done this, all I want to do is just return whether either of our conditions are met. So we can do that by using an or. So now if either condition 1 is met, where B is close and C is far, or condition 2 is met where C is close and B is far, if either of those two conditions are met, we return true, otherwise we return false. So yeah. If you have any questions, you can write them down. Doesn't seem like there's any questions. So yeah, we'll move on. We're running out of time a little bit. So this is the last one that we're going to be doing. I can't really give you guys too much time for this, but yeah, we'll try and make do. Make chocolate. We want to make a package of goal kilos of chocolate. We have small bars, 1 kilo each, and big bars, 5 kilos each. Return the number of small bars to use, assuming we always use big bars before small bars. Return -1 if it can't be done. So this is really similar to the first one that we did in Logic 2, make bricks. But instead of checking whether we're able to do it or not, we have to return how many small bars we use. So like if we have to use all 4 of the stuff that we have, then we output 4. If we only have to use 2 out of the 4, then we output 2. And also, if you're not able to do it, you output -1. So like for example here, this also make sure that you know it starts with small bars, then it goes to big bars, and then it goes to the goal. So here, if we have one big bar, so 5 kilos, plus the 4 small bars, the maximum we can get is 9, which is less than 10. So we're not able to get 10, so we output -1. Here we have 1 5, and we only need 2 of the 4 here to get 7. So we output 2. Here we have 1 5, 1 5 kilo plus the 4 extra. So since we need to use 4 small bars, we output 4. So I'll give you guys, I mean, we don't have much time. I kind of just have to go over the answer right now. So yeah, sorry. Yeah, sorry about that, but we kind of need to, we're kind of in a time crunch. So what we want to do here, we want to make our maximum equal to goal divided by 5. So that's the maximum big amount that we have to use. Because if we have an excess of big, then we can't use like all of it. So if we have more big than the amount of big chocolates that we need, then we also need to check for if the amount of small chocolates that we have, if that can get us to the goal. So here what we're doing is just making sure that if we have excess amounts of big or the exact amount, because of course if we have less, then it's kind of hard to, well, that's a whole different situation entirely. I mean, but if there's an excess of big, we want to make sure that we have enough small for the remaining amount of amount of kilos that we need. So if both of these are met, we can just return goal minus max big times 5, because that would give us the amount of small bars that we need, because they're just 1 kilo each. And we need to check the other situation where if big is not enough for if it's less than max big. And if this is the case, we need to check if the amount of small can get us to our goal. So basically the kind of the same thing. Oh, sorry, wait. It has to be big, not max big, because big is a smaller one. And then here we just return the same thing, except instead of using max big, we use big. And if we're not able to do any of these, we just return -1. So basically, this checks whether we use big or max big, depending on which one's smaller. And then we do essentially the same thing where we try and figure out if we have enough small to be able to get to our goal. And it just changes max big or big, depending on whichever one's smaller. And then we just return the goal minus the amount of big that we need, so that we can get the amount of small that we need. And if we're not able to do any of those, we just return 1, or -1, sorry. So yeah. I'll leave this up here for a little bit. Unfortunately, it is past 12, so we are going to have to wrap up here. So your homework is going to be warm-ups 1 and 2 for coding bat, and you're going to have to do some Python for beginners for solo learn. So hold on, let me. Yeah. Make sure you guys do your homework. Unfortunately, we're gonna have to end it for today. So see you guys tomorrow, I guess. Yeah. See you guys tomorrow. Bye.